So the next form of condition monitoring technology that we are going to be looking at is the oil analysis, lubricating or lubrication oil analysis. That's what we'll be looking at. Now, we have outlined some other condition monitoring technologies. We've looked at the vibration analysis, we've looked at the thermography, and then we've also looked at the physical inspection, like feeling and visual inspection. So all of these condition monitoring technology, you will observe that before the fourth condition will deteriorate to the stage that you can feel the heat, or to the stage that the vibration will have increased, or before it can impact the vibration of the equipment at that particular location where you are collecting the vibration information, or before the anomaly will show up in your thermogram, you will see that some level of deterioration will have taken place, especially when you are looking at internal combustion engine, compressors, and other equipment, okay, whose internals does not have reconnection with the external of the equipment, okay, or the external body of the equipment where you can take those information. So you see that in such case, the lubricant that is going through those internals will give us better information about what is happening inside of those equipment. So this is the reason why oil analysis is very, very key or more feasible in some equipment. So it's now left for us to try to determine which of these technologies will give us the results that we need in our facility. So we are going to look at oil analysis, and then we will look at what we need to do in carrying out our oil analysis, and how the degradation in the oil, okay, tells us something about what is actually happening within the equipment. So under this section, we are going to first look at oil degradation and contamination. What causes those degradation, what causes those contamination, and what those indicate, okay, the degradation and the nature of the degradation and the nature of the contamination. What does it tell us about the condition or health of the equipment? So we are also going to look at some oil analysis technique, at least the common ones. We are going to look at them in this section also. So we are going to look at some of the standards and guidelines we use in oil analysis. And then finally, we'll look at some case studies, how the reliability of plants have been improved with the deployment of oil analysis, okay, and other condition monitoring technologies. So oil degradation, what does it stand for? When we say a lubricating oil have degraded or is contaminated, okay, degradation simply means that the chemistry has been altered, which means that the oil is no longer fit for purpose because certain components, their nature have been changed, or some have been destroyed in the course of lubricating the mating parts of your engine. So common causes of oil degradation, okay, that's what are some of the things that can cause the oil chemistry to change or to degrade, okay. So as you can see, these are the things, some of the things that can cause your oil to become degraded or no longer fit for use. Okay, the wear particle content, the chemistry and the viscosity, as we said earlier. Okay, then contamination level. Okay, so this is the trivector that we use to kind of know whether the oil is still fit, the lubricant is still fit for use. Remember, the more wear particle that we have in the lubricant gives us an indication as to the fact that there is a part in inside the equipment that is wearing that fast. So further analysis of the wear particle, that is when we carry out wear particle analysis, as we will see later, you'll see that we'll be able to determine which of the component parts in the engine or in the equipment is actually wearing. So that will also assist us in trying to know what is the cause of such wear. And you also agree with me that the more the wear particle we have in the oil, and the more we have in the lubricating oil, you see that the more the possibility of increased wear of those internal parts, even the part that have not been wearing before, because those particles will be sent to those parts, and as the engine is working, it will cause further wearing of those parts and thus increasing the wear. So wear particle testing and determination tells us the nature, okay, whether the oil is fit for use, or equipment itself, okay, is working properly, or some parts are wearing or not. Okay, so the chemistry too will also tell us if the equipment is working properly, or the oil, the lubricating oil, is still fit for use. Remember that the chemistry determines the nature of the oil and whether it will do the work effectively, okay, that we want it to do. Are we getting it? So once that chemistry is altered, especially of the additives and of the oil itself, you see that they will lose those ability. Just imagine you have an antioxidant that its chemistry has been changed. That is, the functionality of that component, okay, has been removed from the oil. That will mean that the oil will no longer be able to have that antioxidation properties, okay, on the meshing parts, the oil, which means that the possibility of oxidation happening within the parts of the equipment, okay, will be there. Then contamination, the level of contamination of the oil will also tell us whether the oil is fit for use, or the wearness of the equipment. We know that once we have contamination, that means something external, okay, is coming into the oil, which could be as a result of leakage. Okay, so if we have leaking seals, leaking gaskets, and what have you, so these contaminations, the contamination level will give us an idea as to whether these those parts of the equipment, they are functioning properly. So we want to see some common causes of lubricating oil degradation, as we said earlier. Okay, so the first one that we'll be looking at here is oxidation. Oxidation. So what does oxidation do? You will see that oxidation can cause an increase in viscosity of the oil, which means that the oil chemistry has been altered. It tends to link the oil molecules together, thus forming larger molecules. So that will invariably increase the viscosity, okay, of the oil. And once the viscosity is increased, which means that it may not be able to penetrate those joints, those meshing mating surfaces, okay, those little clearances that they want them to go through, and those places, those joints, those positions or those points will no longer be lubricated, and that will increase the frictional force there and thus the wear and tear of the equipment. So oxidation is not something that is good for the oil itself and for the operation of the equipment. So you will see that the oxidation also can lead to the formation of sludge, okay, sludge and varnish. And this sludge, as they are forming, you see that it increases the contamination level. Are we getting it? Of the lube oil, and that can cause the blockage of filters, okay, of strainers, filters, and also cause the seizing of mating parts, because they can go and lodge in those mating parts, the space between those mating parts, and increase the that is increase the forces that the mating parts will need to overcome before they will turn, and it may cause the parts to seize. Are we getting it? Or bind. So oxidation is something that is not too good. And oxidation also can cause the increase of the acid content, okay, of the lube oil. And we know that as the acid content is increasing, or the acidity of the oil is increasing, that can enhance or increase the possibility of corrosion within the engine. So you see, oxidation is something that can affect the lubricating oil and thus the equipment. So it is something that we really need to guide against. So which means that the oil with the required antioxidant, okay, we need to be sure that we have such an oil in the equipment. Then contamination. Contamination could be external or internal, okay. Contamination from the external could be that we have leakage somewhere, which could be maybe cooling water is leaking into the lubricating oil system, okay, or process fluid or diesel, that is fuel, is leaking into the lubricating oil system. So that can reduce the viscosity if it is fuel, reduce the viscosity, change the chemistry altogether. And then at the end of the day, that will affect those parts, okay, on which that is all the lines, the parts along the line through which the oil will go through. Okay, and if the contamination is from cooling water, you see that that will increase the corrosion. Are we getting it? So contamination could be the ingress of oxygen also, that will also can enhance corrosion of the engine parts through which the oil goes through. So we want to be sure that the lubricating oil, as much as possible, is contamination free. And we want to also be sure that we operate the equipment rightly, so that the maloperation will not lead to oxidation that will eventually lead to the formation of things like sludge that we talked about earlier, okay, that will also affect the chemistry of the oil. So thermal degradation also, that is exposing the lubricating oil to excessively high temperature. So we know that once that happens, it can cause the disintegration of the oil molecule, okay? And then it can even increase oxidation, give the right condition for oxidation to take place. Are we getting it? In the oil and on the equipment itself. So we want to be sure that the equipment is operated at the right temperature, does not go beyond the normal operating temperature of the equipment, because all of those, once you overload the equipment, that will eventually lead to overheating and what have you. All of those will be transferred to the oil, cause degradation of the oil, and then eventually affect the engine parts, which will eventually also increase the thermal stress on those parts, because as the frictional forces are increasing, what will happen? The temperature will also go up. So thermal degradation is one cause of lube oil degradation. Okay. Then we have mechanical shear, that is subjecting the lube oil to excessive shear stress. Okay. So when it is subjected to excessive shear stress like that, you see that the polymer molecules in especially multigrade oils, okay, will be stretched and at times even be broken, and that will affect the viscosity of the oil. Okay, so once the viscosity of the oil is reduced, what will happen? You will see that it will not be able to provide that lubricating effect that is necessary or that is required to prevent the metal parts from wearing, okay, because of that reduced viscosity. So mechanical shear is another factor that can cause degradation of oil. Are we getting it? So another thing that can cause is microbial contamination. Okay, so once there are microbial activities, that can in some instances enhance the oxidation, okay, in those areas. And oxidation, as we have explained earlier, reduces the chemistry of the oil, okay, and then of course can even affect the engine parts or the equipment parts, causing oxidation in them. So these are some of the common causes of oil degradation that we want to guide against. Okay, so from what we have discussed so far, it is now clear that in the course of normal operation, degradation can happen. Are we getting it? Degradation can happen. So how do we look at, what are the various techniques we can use to look at the integrity of the lubricating oil, so as to know if the oil is still fit for use, and also to have an indication as to the wellness of our equipment or the condition of our equipment. Remember, this is also a condition monitoring technique or technology. Okay, so the first is viscosity measurement. Viscosity measurement. So you take sample of the oil from the equipment, okay, and test for the viscosity. Of course, as the viscosity is going down, we know that the lubricating capacity of the oil is also reducing, which means the mating parts that you expect the lube oil to lubricate, okay, will have more, or let me say less lubricant. Are we getting it? And thus increasing the frictional force between those mating parts, and eventually increase wear and temperature of the equipment. Okay, operating temperature. Then we also look at the acid number. Okay, that's to determine if the oxidation also increases the acid number of the equipment. So we look at the acid number, and we know that the more acidic the oil is becoming, the more corrosive, okay, it will be. So it gives us an indication of the fitness of the oil in our equipment. Then the water content. Okay, that's also to determine the contamination level. And we know the higher the water content, in fact, if there is water ingress into the lube oil, it will affect the viscosity, affect the nature of the oil, the lube oil, okay, change the chemistry of the lube oil, and increase the oxidation of the engine parts. Are we getting it? And that will eventually increase the wear and tear, which will further increase the contamination of the lube oil, because those oxides of metal that will eventually form will flake out and then contaminate the lube oil further. So we are going to also look at do the particle counting. It's another analysis technique. Okay, so that gives us the concentration of the wear particles, okay, per unit volume of the lube oil. So we have what is acceptable, and we have what, if it goes beyond certain limits, we know that will affect our engine. Okay, so spectroscopic analysis also is another form of the lube oil analysis that we will be looking at. So let us look at the major techniques that we go through in carrying out this lube oil analysis. So for you to analyze the oil, first you have to take sample of the oil. Okay, so your sampling points need to be fixed. That is, each time you go to take sample, it must be from the same spot or the same point on the equipment. Are we getting it? And then secondly, you see, like this pump, this hand pump now, you see this tube is connected into through the sampling point, okay, or sampling hole into the sump where we have the oil. Then it is also very important that you do not allow the tube to get to the base so that it does not pick up sludge. Are we getting it? From the oil. And again, it is also better when that is, if you must put off the equipment, okay, should be immediately after you put off the equipment. But if you can sample while the equipment is running, of course, that is also fine. So the sampled equipment, the sampled oil, you label it appropriately, and then you now take it to your oil analyzer. So in the analyzer, okay, the analysis is done, and all the oil chemistry will be determined. The level of contamination will also be determined. The viscosity in some cases, or you have a separate viscometer to test for the viscosity. Okay, so the oil chemistry, the contamination level, and the wear particle, okay, content of the oil, all of those will be analyzed in the analyzer. So we also have handheld analyzer that you can actually carry into the field that will give you some of these results, okay, right there in the field. So let us look at wear particle analysis. The wear particle analysis in some instances will give you, as we said earlier, an idea of the parts of the equipment that is wearing. Okay, and if you know the parts of the equipment that is wearing, of course, that will also give you an idea of the possible cause of the possible cause of the wear that the equipment is experiencing. So this is the wear particle analysis of an internal combustion or reciprocating engine. As you can see, you have the piston, rod, and you have the crankshaft. Okay, so we have bearings on around the edge of this piston rod, okay, where it is connected to the crankshaft. We have journal bearings. So if you look to the left of your screen, okay, the presence of all of these metals will give you an idea of which part of the equipment is actually wearing out. So if you see, and then we have the contamination level of this wear particle that is acceptable, the one that is will tell you that yes, you have to be very careful. Okay, that is the alarm, the warning level, and then of course the alarm or shutdown level. Okay, to tell you that the wear is serious. Are we getting it? So if you have this sodium, you have sodium, that is when you analyze the oil, and you have about 35 parts per million. Okay, 35 ppm of sodium. That will tell you that you should be very cautious. That is a warning level. Okay, then once it is 80 and above parts per million, then that's the alarm level. So now all of these parts, okay, all of these metals or all of these components, okay, they are used for the manufacturing of different parts of the engine. So like the rings now, you see they are made of chromium and molybdenum. So if you have chromium up to 10 parts per million, okay, that will tell you that the rings are wearing out very fast. Okay, so what could be causing the wear out of these rings is now left for you to determine, okay, and see how you can prevent that for deteriorating further. Then the piston itself, you see, is aluminium. Okay, and this is the aluminium, and this is the wear particle content level, okay, that is not acceptable. You see it? So we need it to be less than 12 parts per million. Okay, so if you have more of aluminium in your oil, it means that the piston is wearing out very fast. Then the sleeve, the liner of the cylinder, okay, you see it is made mostly of iron. So if you have iron, you know it is the sleeve, okay, that is wearing very fast. And then the bearings, copper, lead, and tin, okay, they are some of the metals that are used in producing those bearings, those metal bearings. So once you have them, as you can see here, okay, you have tin, you have lead. Beyond all of this level, then it should give you a cause for concern. Then the water content level should not be more than 0.2%. Okay, if it is more than 0.2%, then it should give you a cause to worry. Then fuel contamination too, and then if the viscosity is less, is more than that is when you compare the viscosity of the used oil to that of the used oil, okay, the one you sampled, to that of the unused oil. That's the oil from the drum. Okay, remember, you in carrying out this analysis, you create your baseline information. That is the fresh oil that you have not used at all. You test them to get an idea of the chemistry of the oil. Okay, so once you have the chemistry of the oil and the viscosity and what have you, then subsequent sampling and tests that you do will be referenced to it, so that when the oil is degrading, you will know clearly. Okay, so these are the metal bearings. You see the pass with which it is made. Okay, so in reciprocating engine, condition monitoring techniques like vibration and what have you, and infrared thermography will not be too effective. Okay, because we have so many forcing function on that vibration. So we can use the overall vibration level. Okay, but here you see that the movement of the piston will contribute to the vibration. The movement of the crankshaft will contribute. The movement of all of these valves, the camshaft, the cam followers, okay, all of them, even the gears, the timing gears and other gears behind, all of them will contribute to the overall vibration. So trying to identify each of these forcing function will not be too easy. Okay, so, and like we said earlier, before all of this will even show up as increased vibration, that will mean that the wear have deteriorated to a very large extent. Okay, so as you are carrying out the wear particle analysis, before it will show, that is the oil analysis, before it will show in vibration, okay, you see as increase in vibration, you see that you would have seen it in the oil. So all of these too, as we have discussed earlier, okay, will give us an idea, not only to know that the oil is getting contaminated or the chemistry is deteriorating, but to also tell us the parts of the equipment that is wearing out. Okay, so on the rolling element bearings too, okay, all of this, see, if you have silicone, more silicone in your oil, that shows you that we are having dust and dirt ingress, okay, into the lube oil system. Okay, or sealant, sand, some of the additives and the synthetic fluids, they are all getting into the lubricant. Okay, so once you have aluminum in your lube oil, see the pumps parts, the white metal bearing, truss washers. So these are the parts that you'll be suspecting that are leaking. Then if it is a rolling element bearing, you have more of chromium, okay, copper, the cage metal in a roller element bearing. Are you getting it? So gears, shafts, bearings, okay, if they are wearing out, you see more of iron in the lube oil. So bushings and bearings, more of lead, okay. So all those your metal bearings, you see more of tin. Are we getting it? So all of these are some of the things that we need to look at. Okay. So here is a summary of the wear particle analysis and the common sources, okay, of those particles that you find in the oil. So if you have silicone, that is dirt, okay, is getting into the oil in the engine, then sand or the sealant, this could be the possible source, okay, of silicone. Aluminium, the oil rings, the truss collars, the sleeves, bearings, okay. So that is what you'll be suspecting if you have more of aluminium, okay, and even your piston, okay. So chromium, you should be suspecting the cams, the shafts, okay, then all of those races. Are we getting it? Then iron, the cylinder walls, your valves, your valve guides, okay, the cam, All of those are possible parts that could wear, that will show up as more of iron content, increase in the iron content in the lube oil. Then lead or tin, then the sleeve bearings, okay, or both. Are we getting it? So those are some of the ways that you can use to identify which part of the equipment is actually wearing.